Alright, it is cold here today, 54 degrees, and I know Paul up in Maine is laughing, and I know Pierre up in Canada, where everything is frozen, is chuckling at me. But this is Southern California, and we're not used to 54 degrees. First, I'd like to thank everybody for leaving comments. Any video, most of you guys don't know, you're not YouTubers or creators, but any video that I've done, if a comment is left on it, I get an immediate email and I can go back and read it. But it's really encouraging to know that all the time, effort, work is appreciated by people. To read, hey, another great video, Dave, keep them coming. I love it. Alright, for this video, I had a lot of fun making the flame liquor engine, which is behind me, that everybody's probably seen that video. Ever since then, I wanted to make another engine, more on the order of gas or something like that. But I didn't want to mess around with spark plugs and ignition coils and so on. So I kept looking at different steam engines and things like that, and I stumbled across this diesel engine on YouTube. And it looked really promising. Found the print, which I'll show here coming up, on it, and the print looked good. But I really, my advice, maybe you could say, is doing something like this, a complicated, long project, really pushes you and the shop. You'll find out real quick whether your shop has all the tools necessary to make it, and you wind up learning quite a bit. I learned quite a bit doing the flame liquor engine, so I knew I had some experience to apply to this project. So it took quite a few weeks, and there are some parts in here where I won't be saying anything. Your audio is fine. I came down with the flu like everybody else, and there's a point where I completely lost my voice. So, and quite a bit of this you're going to hear my voice is shot, but I still kept taping and showing and working on it. So here is a diesel engine, and the other thing too is a lot of research and the fuel for it. There is one video I found of the guy mixing the fuel and telling you everything about it, but you can't get half of the ingredients for it. So, but I still wanted to make the engine, so I hope everybody enjoys it, and this is probably going to be a two-parter. So, alright, there's the first page of it, the Boll Aero 18 diesel. I've seen it on YouTube, some of them running, and it's pretty kick. So I found this print, and it's pretty easy to follow. I mean, here's the first part. I haven't shown much machining on it. I just took 1 inch because the print is very clear, very easy to read. Whoever this CAD guy was that drafted this up knew what he was doing. Just the right amount of detail and not too much detail. So I just took a 1 inch piece of aluminum, fly cut it, the sides. They want 1 inch. I'm now down at 0.989, basically 11 thousandths skinnier. I don't think it's going to make a difference what the outside of the engine block or the crankcase really is. Then just a matter of boring this out. Drilled it to a 1/2 inch and then bore it, and they tell you where from center to put the screws. I did look before center drilling it here, and it was real close to the edge, so I eyeballed it to where it looked better and modified the print. Rather than 398, I'm at 380, 18 thousandths in this way and in this way. So I drilled that side and then flipped it over using that vise clamp, which is really nice. Put it in there, you know you're on position, drill it, flip it over, hit the clamp, you're on position. Makes the work a lot quicker. So I did all that, then drilled this, bored it out. Same thing. They wanted what was it, 440s all over the place. Even this, I did take them in. I think, oh no, I didn't modify the print. Yeah, I did. They want 398. I came in 370, or 370 from center. So that was done. For some reason, the Y-axis DRO decided to fail on me. So you can see this gap here is smaller than this gap to this screw. So I figured I'll make this the back of the engine, because it's just a plate and it'll hide that little error, and that's going to get bolted to something anyway. So if I make that the back of the engine, then that means I need to put the carburetor on the face on this side. So I figured that, and they show you very clearly here. Come down 290, it's a 5/16 24, piece of cake. Flip it over. This one was spooky because it's so close, and the guy actually looks like it's not to scale, but it's relevant, or whatever you want to call it. It's in somewhat of a scale. So drill it out, and it's an interesting, because everything here they have imperial first, and then they have metric below it. This hole to be 1.177, that's a metric bit. So I drilled it, and it's right on the edge. I did hit all these edges, deburr it with the stone, the sharpening stone, so you can see all the edges. Let me zoom in a little bit so you can see more of this part here. A little closer, telephoto. Alright, there it is. I haven't done the surface yet on sandpaper, because I know I've got to still do this angle piece that they show right there. And for that they want a radius of 0.675, which isn't much, because I set this, 676. Did it in the camera view. So if I go across the center of these holes, you can see I'm just barely clipping it. And they want it rounded. I could put it in a 4-job, but I'm not gonna. I think I want to build the cylinder head first, see how it fits and looks, and then I'm just going to chamfer this. I'll just use a 45 degree, and Bert come down some distance. What do they call out for the distance? Do they call it out? Yeah, it's over here. So they want to cut the distance to 438 thousandths. Some of these dimensions are really weird to hit it like that. So the next thing to build, I guess I'm going to do the cylinder. Actually, the next thing up is the back plate. It took me a while to find this outside diameter. They want 1.5 inches. And I'm looking at that. I don't know if you can see it. That's a 1.5. That's not going to leave very much on the sides here for mounting this to something. So I've got a piece of 2-inch, so I'm going to go up to 2 inches on the outside. And then they say where is it? 4 required something. Countersink for fasteners selected, because you want it flush on this surface so you can bolt it. So the thickness of this isn't much. It's 150 on 440s, so I may change this to thicker. I gotta actually pick I want to use, I guess they'll use these beveled screws or whatever you call them. I'm gonna probably use socket heads in here, so I'll probably change this thickness accordingly. And it looks like it's got a fairly thick wall. It's because this is 750 to 840, so that's about like a 90 thousandths wall in here, this little thickness here. So I guess I clean up the lathe or mill first, package it up or whatever, and then start working on this back plate. Nice. Early in the morning. Why does it look like it's moving in the camera? Got my coffee, kind of quiet, the wife's still sleeping. This is crazy, let me tell you. this is going to be the back where it goes, but it's right, there's not much of a wall left, but it goes right in there. Boom. So luckily, because I was originally planning, I was thinking that was going to be a little beefier, so I was just going to turn it around and put it in the 3-jaw. But luckily I do have a collet that fits this. So clean up the lathe, because it's a wreck trying to turn 2 inches down to 3/4. There's chips all over the place. Put this in, I just gotta turn this down, face it. Then, yeah, I got the screws, so there's plenty of room. Then, I guess I could put this, yeah, I can put this in a collet block. Find center, and then drill the holes out that are supposed to be there. Because I think they're further out. Yeah, I can always poke it up a little bit. Yeah, I can poke it up quite a bit. But I have to see where the holes are that I can drill and not hit my collet here. So, just finished running the bottom tap through all of this. I still have to do these. But it's coming out. This is kind of cool here. So, ta-da! One motor mount. It's always scary because you spend hours making the basic part, turning this down, and then if you screw up the holes, you don't want to do it over again, but it lines right up. Like, wow. So, there it is. So the countersinking was good. Wish I had a smaller end mill. That's why I probably need to just start getting metric. There, that one just fell in. So, yeah, they line up. Alright, so next up, I guess, is what? The front of the engine. Alright, so I'll have to stare at this print for a while. This is going to be fun because I'm going to do it with square stock. 4-jaw chuck, turn it, and then I guess, yeah, go to a collet. How big is it? I think I got a collet, so then I can wind up turning the back of it and get it precise, because yeah, the back has to go right in here. So that'll be kind of cool. And I just drilled a 1/4 inch. I didn't even follow the print where to put the holes. I just eyeballed it and said, alright, that looks good. What's holding it? Oh yeah, screws in the threads there. Okay, next up, front of the engine. And I'd love to just bevel this whole front, bring it to a point rather than square. Yeah, I could probably do that on the tip, because then I'll have enough still for the collet to hang on to it to do the back. Alright, progress on this front piece. Square piece, 1 inch, was put in the 4-jaw chuck in the other leg. Turned down, I've got 550 on the other end. Then this got, because the chuck made marks on it, this was just put in the vise, fly cut, all the 4 sides here. And so now I'm just turning this part down for the diameter that goes in the front of the engine. It's kind of a kick, makes a funky noise, but yeah. Using one of my just generic inserts rather than beating up my favorite aluminum one. But this needs to come down to, what was it, like, it's over 3/4, but and I'm almost around here. And then I can round out the corners this way too on the square part, so it looks a little bit more neat. There we go, we're finally getting square. Yep. No, that was a little bit off. And then I can use the same thing here to drill the hole. So it's just a matter of taking it down now to the right dimension. So just thought I'd shoot a little bit of that. I'm sitting here looking at it. This guy, this was like almost a whole day's work just to do that. Still got a lot of cleanup to do, burrs all over it. But I made this from that surface out way longer because I'm looking down in there. I actually drafted this thing up to scale on my computer, but so that's why I'm figuring how thick is this flywheel in here. That was one of the first errors. It's on one of the print. It took me a long time to find the diameter of the flywheel that goes in here, or cam or whatever, and it's like 0.8 something and it won't fit in here. So this guy, I forgot to put the round in it, and it's kind of big. I don't know, I might take it down more. I mean, they show this piece is going to match it, so I don't know. But the other thing too is the shaft that goes through here, there's nothing on the back holding it. It's just the cam or crank or whatever sits here, and that's it. And I think the only thing that keeps it from moving is it hits this face, and then this piece keeps it together. So you got to do this shaft, and where they come up with these dimensions, the hole is 0.313. That's really strange. And also on these holes, these should have been in. Even though I moved them in, they should have been in a lot more, because I did, when this was in the lathe, I did hit this to round it. It kind of looks round. I was going to go in further, and I'm glad I didn't, because I'm right on these holes. I was also wanted to take this in more, so it wasn't quite, square with it. But I'm glad I didn't, because I would have messed this part up. I wouldn't be able to get these holes. They could be in a lot. So if this engine works, I know I'm going to be redrafting this thing, changing this dimension. I'm probably going to machine something that press fits in here that holds the back of the shaft, because you're going to be just pounding on it, and all the pressure is going to be right here. So far so good. Wow. Alright, so far so good. Drilled that all out. Looks pretty cool down in there. The part sticking in there is oversized, so whenever I make this little flywheel that goes in there, I can compensate so that I'm on center with the piston rod. I decided not to drill this hole because I forgot. I think they wanted to make the rod out of steel, and I don't know what size I want to play with yet. I was thinking about making it out of brass, but I can push that down line. I don't need to do that yet until I start having to build the actual shaft that goes in there. So the next part up here is the cylinder, which goes down in here. This part right here drops in, and I guess this is saying that's the exhaust port, and it lines up this guy. So I guess that's the exhaust port. And I'm not exactly sure how fuel gets up in here, but I'm stuck for now, because it says this is the first part that they want to make out of steel, and they want 12L, and there's no way I'm going to get a very nice inside cylinder wall out of 12L. So I either make it out of 1018, which is also, forget it, not going to get a good finish, or make it out of stainless or 1144. So I don't have a piece of 3/4 stainless to work with. I did a quick test, and this groove, which is 3/16, I can machine a nice groove with my 3/16 grizzly bit in 304. So I only have a 1-inch piece, and I don't want to do this part in the 3-jaw chuck. I want to do it in a collet. So I got to find either a 3/4 stainless or 3/4 1144. I'd really rather do it out of 1144, because I know I'll be able to get a nice clean groove. My test was fine. So I'm kind of stuck right now. I guess I got to look for some material and see what I can find. That's pretty inexpensive. Look at that, man. That's a nice alignment. 380 thousandths off center. So, and I'll probably chamfer just the two bottom edges, make it look a little bit better. I really wish I would have modeled this thing first to actually see how everything was going to line up, because I would have changed, like I said before, a lot of these dimensions here to make it look better. Yeah, because look at where these screws are. They could have been way the heck in here. And like I said, this should have been the back support for the shaft. But, alright, let me find some material, because this is the next part that needs to be built. Oh yeah, I was reading some of it. This is controlling compression, which is scary. Just this threaded piece going down into the cylinder changes the volume of the cylinder, thus the compression. So that little bit scary. That would mean that I've got to get the piston rod and all of these dimensions right on the money to see if this thing is going to fly or not. But onward and upward. Alright, figured since I'm stalled here, is there any other part I can make in the meantime? The carburetor. So, piece of 1/2-inch brass rod goes in the lathe, turned down to 5/16 threaded, 5/16 24, goes into a collet block square in the mill, machine off 4 sides here, drill through for a 632, tap it all the way through, flip it over, drill the threads out on the other side, which wound up being .144 drill bit. So basically there, and then drill that out. Turned out to be metric, the size that they wanted. .217, I'm .2165. So that's drilled all the way down. So now I guess I can just cut it off here, stick it in the collet, and turn this other face here. But pretty trick little guy. And the print here, you can see what they're using for a needle valve. I mean, this little guy I gotta make screws up in here, the jet's right here in the middle of it, and you're throttling how much fuel comes out by this guy's a plunger. So when I build this, I'm going to try to use a traditional screw type needle valve and see if I can do something that way. Do they show an angle on this? Yeah, they do. They just show a length, 1.5 inches long. I don't know, because I guess it's a friction fit. You're just trying to push it up and down. They don't give the angle of this. I guess you just bring something to a point. So that's missing. I don't see. Yeah, there's nothing here. So, alright, onward and upward. Making the jet thing for the carburetor. I have to drill a 55 thousandth hole over 1 inch in. And I was doing it dry and the bit just keeps clogging up, but with the anchor lube it makes a big difference. Just a little bit on the bit. If I can get it on there. And I'm just pushing, because I got to keep clearing the chips. I'm just pushing it in by hand. With the anchor lube it just goes right in. You can easily push. Almost there. Look at it just go in. It's beautiful. That's it. I'm at depth. Wow. So I only need to go in this far. Oops. I think that's out of the camera view. There. Yep. I'm beyond where I need to go. So, incredible. Thank you, Anchor Lube. First time I've actually used the live center. That's the only way I'm going to get a good finish on this. Why does it seem like that's tight? Seems like I'm probably eating into this hole but I've made it far longer than I need to, so let's see what happens here. This will be the final cut. Trying to make a nice finish. With that rod vibrating, it's a pain. Alright, here we go, hand fed, huh? Try to keep a consistent speed and not stall. Come on, keep going, keep it nice. Looks like I'm still gonna have to sand it after all, I don't know. 2000's cut. Yeah, I hiccup. There's a mark. So that's that, huh? And done. Wow. Doesn't look too bad without the light. Alright. This is an entire day's work. Whoa. 55 thousandth hole through the end. A number 61 39,000th drill bit. Right through it. I don't know how you get rid of the burrs on this stuff. There's the drill bit. Jeez, because I can see there is a burr in there. I don't know how I'm going to do this. I guess I'm going to have to do this off camera so I can see what I'm doing, but it goes right in there, and all these dimensions are critical so that that hits the inside to seal it, the bottoms out, and that hole when you're bottomed out has to be in line with the thing right there, straight up and down. Crazy. Yeah, I guess you think you can see it. But, and I think they're just using a regular sewing needle for the valve. So I was going to try to get a regular valve, but I just realized how this thing works. I could probably try to do it on this end, and then I was just going to use fuel line that I've got lying around. I could, yeah, I could reverse this. Make this the top, and then just put a needle valve screwed in there to control it. But an entire day's work. It's crazy.